So children, now we are going to discuss law of conservation of energy. There are three cases, children. In ninth class, there are three cases. In 8th class and ninth class, there are three cases. One is freely falling body, one is upward thrown body, and one is pendulum. This and this cases I will say today, children. This case I will say tomorrow. Okay, so two cases I will say today, children. One case tomorrow I will say, children. All of you. So pendulum and freely falling body I will show tomorrow, today, children. Law of conservation of energy I will show today. Please, all of you should concentrate, children. No? Okay. Now, what is the law of conservation of energy? Energy can neither be created nor destroyed. It is called law of conservation of energy. Law of conservation of energy means energy can neither be created nor destroyed, but can be changed from one form to another, one form to another. Children, one form to another. Okay, you can convert one form of energy to another form of energy, but you cannot create nor destroy energy on this universe. That is called law of conservation of energy. Okay, you are doing your work. From where you are getting energy? Because you are eating food. You're from where food is getting energy? From plants. From plants, where it is getting energy? Sun. Sun, how it is getting energy? It is creating. Okay, but we cannot create energy nor destroy energy. In sun also so many reactions will occur, children, because of that energy is created. So finally, whether it is law of conservation of mass or energy, we cannot create mass or energy, or we cannot destroy. Only we can convert from one form to another form. If we eat food, then we can do our daily works like that. Okay, so if you are bicycling, you are cycling a bicycle, then that energy from where you are getting it is from the food what we are eating, you are getting that energy. And food energy we are getting from plants, plants getting energy from sun, like that. Everything is interrelated. You are not creating, you are not destroying, like that, children. Okay, so children, now first case, in the case of simple pendulum, I want to show you law of conservation of energy. Children, this is simple pendulum. This is called mean position. Children, in mean position, this is mean position. Mean position, this is the lowest position, lowest point. Here, potential energy will be zero. Potential energy will be zero because there is no height. There is no height, children. Here, potential energy will be zero. Whereas kinetic energy will be there. How it will be there, I will show you. Now, take pendulum to one position. Take one pendulum to one position and release it. When you release it, it will go like this, and again comes back like this. So continuously it will move to and fro. Continuously, these both ends are called extreme ends. These both ends are called what, children? Extreme ends. This is called mean, and these both are called extreme. Here there is some height. Here there is some height, but here there is no height. No height. Zero, because it is hanging. Here there is some height. How much height is there? You can see, children. This much height from the mean position. It is there. So at this position, potential energy will be maximum. At this energy, potential energy will be maximum. At this point, potential energy will be zero. So A, point B, point C. Try to understand, children. Very, very important when I am saying. So children, at point A, potential energy will be maximum. When you release it, like this it will go, and like this it will come. So here potential energy will be maximum. When you release it, it will become kinetic energy, kinetic energy, kinetic energy. Potential energy converts into kinetic energy. Here kinetic energy will be maximum, children. Here kinetic energy will be maximum because potential energy fully converted into kinetic energy. Again, as it is going up, kinetic energy starts decreasing and it converts into potential energy, and here potential energy becomes maximum and kinetic energy becomes zero. At the both extremes, kinetic energy is zero and potential energy is maximum. Potential energy is maximum. So children, again I'm saying slowly try to listen. Here potential energy is there. When I will release it, it will go like this and it will come like this. When it is going, potential energy keeps on converting into kinetic energy. So kinetic energy continuously kinetic energy. Here, maximum potential energy becomes zero, kinetic energy will be full maximum. And from here onwards, it's going up naturally. So kinetic energy becomes into potential energy. and kinetic energy decreases, potential energy increases, and keeps on increasing. Potential energy maximum here, kinetic energy. So children, when it is going here, potential energy decreases, kinetic energy increases. When it is going here, kinetic energy decreases, kinetic energy decreases, potential energy increases. Okay, so finally, suppose children, here it is 100 joules of potential energy is there. Here kinetic energy also will be 100 children. Here potential energy again 100. Okay, so children, if you are here, it is 100 joules. Anywhere in its path, it will be 100 only, children. Anywhere on its path, it will be 100. But what is 100? Potential energy plus kinetic energy will be 100. Anywhere in its motion, potential energy plus kinetic energy will be 100 only. But one form of energy is converting into another form of energy. Okay, children. So 100 potential energy, and here full potential energy, kinetic energy is 0. But here potential energy plus kinetic energy will be 100. Here kinetic energy will be 100. Potential energy is 0. Here potential energy is 100. Kinetic energy is 0. In the middle of its path, potential energy plus kinetic energy will be 100. But anyway, it will be total will be 100 only, because we are dropping with 100 joules continuously. It will be moving to and fro. If air friction is not there, 100 joules only it will be keeping in its path. This is called law of conservation of energy in the case of simple pendulum. In the case of simple pendulum, all of you just I'll give 5 seconds time, children. Copy on this. Then I will say freely falling body. Okay, children. Anyone have any doubt in this, children? Anyone have any doubt in this? You can ask me softly. Slowly, softly, you can ask me. I'm giving 5 seconds time. Copy it on, children. If you don't have doubt, then I'll go to freely falling body. So children, last time I'm saying here potential energy will be maximum. Here kinetic energy will be maximum. Here potential energy again maximum. Kinetic energy 0. Here kinetic energy maximum. Potential energy 0, because there is no height now. That's why potential. And again here potential energy maximum. Kinetic energy 0. Why kinetic energy 0? It goes, stops. When stops, no velocity. When no velocity, kinetic energy is 0. So it goes, stops, falls down, stops, falls down, stops, falls down. If it is stopping at the both ends, kinetic energy is becoming 0. So children, what I want to show you is in this simple pendulum, total energy in its motion anywhere is 100 only. But energies are interchanging. One form of energy is changing into another form of energy. But overall, total 100 joules remains as 100 joules only. Okay, I hope you people are comfortable. Okay, children, then we will go to freely falling body. This you should be in a position to explain, children. Okay, you have to take 3 positions A, B, C. At A, kinetic energy is 0, potential energy is maximum. At B, potential energy is 0, kinetic energy is maximum. At C, potential energy is maximum, kinetic energy is 0. Okay, and in the middle of anywhere, potential energy plus kinetic energy, called as mechanical total energy, is constant. Like that, you should write, children. Okay, this is simple pendulum. Now I am going to freely falling body, children. I hope everyone are able to understand. Please listen, children.